Here's Nick. Hey, how's everyone doing?
Doing good.
All right.
I need to get one of those applause apps and play that when you introduce yourself.
Ah, totally. That would be bonus. All right. Well, good morning, everybody. Welcome back. It's hard coming back after 5 days away from school. Even though I know you were doing schoolwork and I was grading and stuff like that, it's still hard, like, for me getting back into the rhythm of it.
I still don't feel like I'm even here.
Yeah. The good news is, this is our last week of classes for fall quarter. So this is week 11, and if it was winter or spring, we'd already be done. So, but yeah, this is our last week, and then next week will be final exams, and then we've got a few weeks off before winter. So that should be a good break, hopefully.
You know exactly what time those are? Because I remember you saying something like maybe Tuesday, but I do have a final that day, so I want to make sure they don't conflict.
Well, let's check right now because I haven't looked. So daytime final exam schedule. So fall 2021, and so this is an 11 o'clock daily class. So I believe it's going to be on Wednesday, 11 o'clock to 12:50.
Oh, okay.
And the way they set these up, they should not conflict as long as the classes don't conflict. So that's the idea.
I don't think I've ever had a class that showed me that schedule.
Okay. Yeah, so, yeah, I just Google clark.edu and then whatever I'm looking for, and it usually takes me there. They change the website periodically, and then the Google links break for about a week, and they catch up. But yeah, it's a good site. All right, let's see. So any questions to start with? I'm going to talk a little bit about PA5. I'm not going to go into a lot of details until tomorrow because there's still some people using a fourth slip day, which means they can turn it in by tomorrow morning.
Was the test 4 relatively quick on most of them? Or did you have any that were like really bad compiled?
Nothing that was like a half hour. There were some that took like maybe 5 or 10 minutes. But I basically had like, multiple windows open, so I was testing different people's code. Yeah. And when they get to test 4, I'd like open up another window and start testing. So that worked out fine. All right, well, go ahead and send an attendance ping so I know you're here. And let's talk a little bit about PA5, and we'll dig more into code details tomorrow. Cool. Yes. So I saw some very very slick PA5s, including a few one-liners, which was nice. Those are dressers. Go for it. Amazon is being good to me here. It's funny, Amazon delivers at like 7:30 in the morning right now where I am, which is pretty cool because it used to be like 9 o'clock at night. All right, so let's make some general comments on PA5. And we'll do more detail tomorrow. So PA5 was, so first of all, good job, right? Pretty much everybody got it to work. A few cases where, test 3 was being picky. A few cases where test 4 blew up. But by and large, most people got this to work. And I think you knew if it worked or it didn't work, right? Because you can run it on the test input files. So that was good. And it's a hard road from the beginning of the assignment to getting a script that works correctly. That's definitely a lot of work. So it was a nice job working the problem and getting to that point. So a few things that I saw. We talked in class about this idea of what's the basic flow of the program. So the idea was, read a line of input, cleanse it, so convert it to uppercase, get rid of special characters, and so on, and then break it into phrases. And then for each phrase, do something with an associative array to tally it. And then do all of this in a loop, right, to read your entire input file. And this was the outline that the document talks about and that I suggested in class. And we talked about two ways to do this reading of a line until you get to the end of the file. You can do a while read line, or you can do a read line and then immediately check this status variable $? To see if you hit end of file. And then cleansing it and breaking into phrases. This is a combination of tr and sed and other stuff. So that's all the weird, quotation marks, @ signs, all that stuff. But this leaves you with, phrase 1, a space, phrase 2, a space, phrase 3, a space, phrase 4. And then this, you do your for in loop. And so each time we iterate through here, the variable that we're using in our for loop will be, phrase 1, then phrase 2, then phrase 3, then phrase 4. And so here we're doing our associative array. So array bracket, whatever this variable name is, equals the current value plus 1. And then when we're done with all of this, and we've hit the end of file, then we, print the results. Which was another for in loop, using the @ sign and the funny notation of going through all the keys, but basically go through and print out each key and the tally corresponding to that key. And so that's the basic flow of the program that I suggested. So the first thing I noticed was that a lot of people completely skipped the whole business of reading in one line at a time, and instead read the entire input stream into a single variable. And some people did this accidentally, I think, because instead of reading a line and echoing it into tr, they just said tr. And if you just say tr or sed, by default it reads from standard in. And so if I pipe an entire file into my main program with a less than sign, if I redirect standard in, then tr or sed or whatever these commands are will just read, every line of that file until EOF. And some people deliberately circumvented this and did, cat dash inside back quotes to say run the cat command, read from standard in, and take all the result of that and stick it in a variable. And that works, right? But it's going to fail at some point, right? What you're doing in that case is you're reading the entire input stream, every line, and you're stringing it together side by side into one memory variable. And if you've got, a file with 1 billion lines in it, you're going to run out of memory, right? Whereas if you read line by line, as long as you have enough memory to process one individual line, you're reading that, you're updating your tallies, you read the next line, you update your tallies, you don't end up, sucking up all the memory on the system. And so this was part of where some of the execution times on test 4 started to get really big, was trying to process the entire input as one variable. So make absolutely sure that you know how to read line by line and detect EOF in bash, right? Because this will be on the final exam. I'm definitely going to have a question where I'm asking you to do something in bash where you're reading from standard in, doing some processing, detecting when end of file occurs, things like that. So if you found a different way to do this because you couldn't figure this out, go back and figure this out, or come by office hours and show me what you were trying to do, and we'll fix it up. So there's one of your final questions. You already know what it is now. All right, so that was one thing, right? Was doing all this processing, um, and when I put things in the assignment prompts, I don't usually put red herrings in there, right? Usually, I'm putting stuff in there for a reason, and it's to not just help you figure out how to do the assignment, but also to sort of guide you along a path of learning that I'm hoping you'll follow, because these are things I want you to learn. So yeah, while read line is one way to do that. The other way is to use the $ question mark after just saying read line. But yeah, the best way is while read some variable do blah 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 done. And each time you go through the body of this loop, this variable will be the next thing that was input by the user. And when they hit Ctrl-D or when you hit end of file, you'll come out of the while loop and start executing after they're done.
So if you do a while loop, then you don't need to do the if statement for the end of file, right?
Yeah, if you do a while read var, then you don't need this.
Gotcha, okay.
And it'll automatically exit the loop when you hit end of file. So what were the main goals of PA5? As far as Bash goes, the main goals were, learning how to read input line by line and detect end of file, working with sed and tr and regular expressions and pipes and all of those details for cleansing, and then dealing with associative arrays, which was the whole tallying aspect. So 3 totally different, probably new to most people, ideas.
Where is the reading line by line? Where would that be most effective? Like, what would you actually use that for? Like, what's a practical use for that?
Well, pretty much everything we do in programming, we're processing some kind of input, right? Whether it's something someone's typing in or something coming in from a file. So if you want to make a spell checker on a file, right, assuming that words aren't split from one line to the next, the easiest way to do it would be to read a line, spell check, read the next line, spell check, read the next line, spell check. As opposed to read in all 100,000 lines and save them into a big long string and now spell check each word of that string. You can do it, but there's no need for that. And it's less likely to blow up by running out of memory if you just work one line at a time.
Okay. Cool.
And sed and tr, for example, do the same thing, right? If I say something like this, right? As soon as it sees that first line, it processes it, it generates output. It doesn't have to remember anything about that line anymore. Now it's ready to take the next line and do its translation and send the output. Now it's done with that line. It doesn't have to remember it anymore. But if you do something like this, right, I'm taking my input and I'm turning it into one big long string. And if I do tr this thing, right, I can get the same output at the end, but the memory use of this is just going to grow and grow and grow. And it's going to make debugging easier if I'm going one line at a time, because the other real goal of PA5 was to get more practice with kind of the whole development process itself for writing complex programs. And this was a complex program not because it was, millions of lines of code, but because the lines were very powerful. And, we had, things that we were piping into other things and complex regular expressions and so on. And when you have a lot of stuff going on in a program, debugging becomes a bigger challenge. And so this was sort of a classic example of where, if you had an algorithm in mind right? Something like this with maybe a little more detail. And if you're comfortable in Bash, if you don't have to go back to your notes to write if statements and while statements and so on, writing the code for this might take you like, 15 minutes. And then debugging it might take you like, 15 hours. And this is typically what happens with more complex programs. And you'll see this, I think, in CSE222. We'll have an assignment, write some code to check the balance of a tree. And it's going to be a 4-line program, right? And you could type it in with one finger, and it would take you, 5 minutes to type in. But it's going to take a really long time to debug. And so one of the goals in working through these courses and working on these assignments is to really, really get good at debugging, right? Because debugging is an inevitable part of the programming process. And if you write your code and you run it and it doesn't work, when you're doing this in a classroom setting, right, when you're trying to learn something, you've just identified a issue with your understanding of something, right? Or maybe a silly typo. Maybe you forgot a semicolon in C or something. But chances are there's some kind of misconception, right? And if you abandon your code and do something totally different, your code may end up working, but you're not going to learn this thing that you really needed to learn. And you're going to repeat that misconception somewhere down the road, and it's going to keep happening again and again until you correct it. If you write your code and it's not working the way you want, and you talk to friends or you talk to Google and you find some different approach, if you switch from doing a read loop to doing, a back quote cat hyphen, or doing a parentheses line less than, right? You may fix your program, but you're not fixing the problem. And there's still some kind of misconception or some kind of notion that you're missing, and it's going to be out there, and it's going to come back again, and it's going to come up in exams, it's going to come up in interviews, who knows, right? So when you write your code, and it's not just a Hail Mary, you've written your code and you're pretty sure this should work, and you run it and it doesn't, dig into it, right? That's where you want to start doing the debugging. And in C we use GDB. What do we do in Bash? Well, we put in a bunch of echo statements. We start printing out what's happening as we execute our script. And so let me give you an example of this. Let's look at a version of PA5. So here it is on test 0. This works fine. Here it is on test 1. That looks good. Test 2 looks good. When I run this on test 3, I get this message, right? And I think some other people bumped into this. Are we going to be allowed to compile on the final? No. No compilers, no execution. All right. So what's going on here, right? There's a problem. So I can start Googling, and I can Google bad array subscript, and I can go down that rabbit hole. You don't need to do that, okay? At least not up front. The starting key to finding this problem is right on my screen. It's telling me line 37, something happened. I may not know what this means, but I know something happened at line 37. So I'm going to go in here, I'm going to say 37, uppercase G. There's where the offending statement is. All right, so what's happening here? I've pulled out a phrase, right, from my for in loop. I've done some cleansing of it, and now I'm trying to see what the current count is. And this looks like the statement that we had in class, but for some reason it's giving an error. Well, count is an associative array, and we declared that up here. let's see what phrase is. Right? It's the thing we're using to access this array. Let's just take a look at stuff. And I'm going to put a message in the front that says phrase equals, because if I'm having a good debug session, I'm going to be printing out 20, 30 different messages throughout my script. I don't want to just start printing stuff and remember, oh, the third one is this, the fifth one is that, right? So I'm just saying phrase equals, and then I'm going to print out the value of phrase, and I'm putting it inside angle brackets. So for example, if there's spaces after this, I'll see phrase equals, hello, space, 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 and then my angle bracket. And we're dealing with spaces in here, and we're breaking things up to spaces and so on and so forth. So we're really interested in that. But in general, anytime you're looking at the values of strings, throw some delimiters before and after to help you see what's going on. So let's just add that one echo statement, and let's rerun my test. And look at this, phrase equals angle bracket, angle bracket. It's an empty string. All right, well, why is that? I don't know. Let's print another statement in here. Let's print out the original phrase. And then down here, I'm doing this thing that gets rid of these underscores. And then I'll print out my final phrase, and then I'll go ahead and use it in the index. Well, my original phrase is just a plain old underscore. So what seems to be happening in here is that something in my input file ended up scrunching down to just a single underscore. Well, if you look at the input file, it's got all kinds of strange stuff going on. And these commas are phrase delimiters, these periods are phrase delimiters. There's lots of weird things in here. But we know where the problem is. It's down here. It's the fact that this phrase is empty. So what's wrong if phrase is empty? What's wrong with this statement? I don't know, but let's find out. So let's make an associative array. Alright, so I managed to store something in data bracket phrase. If I said phrase equal to 2, I can store something in data bracket phrase. What if I said phrase equal to an empty string? I get my bad array subscript error. Right, so we used the line number that we got from the script to dig into the code. We added some print statements with echo to see what was going on. We discovered this kind of weird thing that my phrase is empty. And just for curiosity, you saw that it comes because the original phrase was just a single underscore. And now, outside of the script, we played around with associative arrays and discovered that if phrase is empty, this is going to throw an error. Well, if the phrase is empty, right, it's not really a phrase we want to store. It's something that somehow, got cleansed away to nothingness. So let's go back into here, and let's just make sure that we don't try to use an empty phrase. So we're inside a while loop, right? And so the continue statement says go back to the top of the while loop. So I'm just going to say if phrase is empty, then forget it. Don't do anything with the phrase. I could also say, if phrase is not empty, then do this and this and this. But I'm just going to say, hey, if the phrase is empty, let's just skip the rest of the loop and go back up to the top, get another phrase. So now when I run this, it runs without errors. So adding print statements is like, that's how our ancestors and caves debugged programs. Just write lots of print statements, right? And if you don't have GDB, because you're running bash, or because you're building a circuit with a PIC processor in Engineering 220, right? Do something to convey information from the thing that's running, right? If you're working with hardware, blink an LED. Blink it once in the beginning of your code, blink it 2 times when you get to another point, blink it 3 times when you get to another point, right? In Bash, we can use an echo statement. In C, we can do print statements. We can also do GDB. Here's something else you can do in Bash. We can do this -x switch, right? Which says, show me some information as the script is running. And now, as it goes through, it will show us what's happening, right? C starts off empty. C becomes 1. Count bracket phrase is 1. Phrase was is. Read a line. Echo it. Line is a test period a test. It echoes that. There's the phrases, here's the original phrase, and so on and so forth. This is sometimes information overload. If you do a -x on a long script, it will give you so much output that you can get lost with it. But if you have a simple test case that reduces how much output you get, sometimes that's a good way to go. But I think usually echoes are your best bet. All right, questions about that? All right. So we'll go through details of two-line edit. They seem obvious now. Fix test 3. Yeah. It's usually easier after we see it, right? But the other really important thing is you want to be the person who finds these bugs. Right, and so if people come into office hours and they ask me, what's wrong with this code, a lot of times, especially early in the assignment, I'm not just going to say, oh, you made a typo on this line, right? You want to be the person who discovers these bugs, because if you discover the bug, it's going to sink in a lot deeper what happened, right? So if you've got a syntax error in your program, right? Like you say something like line equals like this, and you get some kind of weird message like this, right? There's a problem with this statement. Right? If that's the line in your script that was blowing up, try it on the command line, right? Well, maybe phrase was wrong, so let's set phrase to hello, and let's run this again. There's something wrong with this, right? Well, we've got a pretty simple statement right here, but let's try making it simpler, and it still doesn't like that. And so maybe my understanding of backquotes is wrong, so let's just try this. And it still doesn't like it, right? And if you hit your head against this, and you keep working on this, eventually you're going to go back to your notes, you're going to look at your other code, and you're going to discover, oh, I can't have spaces on the equal sign. And as soon as you do that, you're never going to make that mistake again. Right? But if someone comes along and says, oh, get rid of those spaces, right? It's just something that you do. And it's not going to register the same way in most cases. And the next time you're typing something and you're switching from C to Bash, you put spaces around there, and you start getting these errors, and it's like, well, I don't know what to do. So debugging is really, really critical. And you want to look at it as not just, dang, I got a bug, I have to do some debugging, right? It's really the emphasis of a lot of this stuff. So CSE222, it's all going to be C. We're going to have GDB available. And we're going to be learning new concepts for most of us. We're going to be learning about data structures. We're going to be dealing with dynamic memory. There's going to be a lot of new things in there. And inevitably, there's going to be bugs. And we're going to have to get really good at figuring out what's going on when our code's not working. And that's probably going to be where most of the time is spent. Yeah, go ahead.
Do you know if you're here or like university, if debugging is going to be emphasized as far as like, here's some code, it doesn't work, debug it, and fix it?
No, but it's going to be
I know in the
assumed.
workplace-
It's going to be assumed that you have excellent debugging skills.
Okay.
Because the assignments you're going to be working on at a university are going to be, you know, several hundred lines of code doing, you know, things with dynamic memory and new concepts like semaphores and mutexes, and working with crazy data structures and a lot of stuff that you'll pull out of manual pages and work with a structure that you have no idea what it does and nobody has any idea what it does, but you're expected to work with it anyway. And and that's sort of, you know, what happens when you're outside of school, right? Somebody wants you to work with a system and you don't have time to become an expert in it, so you put it together as best as you understand it and you start debugging. So yeah, it'll definitely be a skill that'll serve you well.
Yeah, I've heard of stories of people, you know, getting fired or quitting or whatever right in the middle of programming. So, you know, the next developer gets to
Oh yeah.
kind of go through it and find the bugs and whatnot. So I didn't know if that was something that was emphasized.
Yeah, and that's part of the push for the whole kind of software engineering mindset is, you know, not having somebody who creates this Frankenstein code that works great today and then they quit and then next year it breaks, you know. So trying to control how things are developed, this is where you get into things like, you know, style guides where everybody's naming their variables the same and indenting their statements the same and so on and so forth. And that can get to an extreme also. But those are all, you know, nods to making it more feasible for people to be able to debug and modify code that other people have written.
That kind of take out the creativity side of it, though. Like if you're doing everything the way they want you to do it.
It can feel like that. I had a student at a university once, and he wrote me and he said he missed the days at Clark when he could just write code for himself, you know. And if it worked and it satisfied the requirements, that was fine. And he was at a university that had, you know, some pretty rigid style requirements, and he felt like it was taking the fun away. And that'll happen sometimes, you know. The upside is you're getting paid to do it if you're working, and so that's a fair sacrifice in most cases. You know, I'll name my variables whatever you want if you pay me.
Yeah.
Oh yeah. So someone pointed out that back in NES days, people were mostly programming in assembly language. And assembly language is a really hard one to pick up somebody else's code and work with, because that's so low level, and there's limits to how much you can sort of follow a style guide and programming practices at that level. And so a lot of people just sort of started over if they had to pick up someone else's code. I could totally see that. All right, so 222 will be a fun course. It'll be a lot of programming, and it'll all be in C. We won't be doing any Bash, but we'll be using Bash to, you know, compile and make files and stuff like that, plus Git, of course.
Is that winter or spring?
That is winter. That's a few weeks away.
Okay.
And then spring we move on to Java, and that's a whole different experience and its own version of fun. Because then we got like a really powerful toolkit, and we just get to like take the cool toys and put them together and make even cooler stuff. So it gets better.
Java's a lot like Python, right? Where it's just a really powerful.
Yeah. It's all object oriented, and so we have lots of libraries with good classes in them and stuff like that. All right, so let's shift gears and talk about processes. So this is our last week of classes, and Friday we'll spend talking about like wrap up and final exam and stuff like that. But the rest of the week up to then, I want to talk about processes in Bash and in C, and so sort of some of the stuff that we've done. Without necessarily thinking too much about what's going on. I want to think about those a little more right now. So, we're sitting in Bash, and I can type things and things happen, right? And how does all of that work? Well, we know that Bash is a program, or I've told you, Bash is a program, and it's always running. And right now, it printed out a prompt and it's waiting for me to type. And when I type something, and I hit enter, it will interpret what I typed, and if it's, the name of a command, it will run a command. So a process is loosely, it's a set of code that is being executed by the CPU. And so, Bash is a set of code that's being executed right now, but if I type in date and hit enter, another set of code that comes from a file called /bin/date starts executing and prints out the current date and time, and then I get a prompt from Bash and I go back to Bash. So a useful command to know is the PS command. So PS shows you the processes that are currently running on your terminal. And we get a fair amount of information from here. So there's a column called command, and Bash, is the Bash shell that prints out the prompts and waits for commands. Time is how much CPU time it's taken, so it doesn't really take much time. TTY is where this process was run from. And so back when you had, a main computer and you had physical terminals, keyboards and displays hooked up to it, each terminal would have a cable coming out of the back, and it would plug into the back of the computer. And a computer might have, 32 ports that you could plug terminals into. And these ports were called TTY0, TTY1, TTY31. And so this column would show you which terminal had run this command. And we don't have physical ports for terminals anymore. Everything is virtualized. So this console process that I'm running in Unix is called PTS2. That's a pseudo terminal number 2. And if I start a new process, a new terminal window, and I say PS, this is pseudo terminal 3, PTS3. And if I start another one, that's PTS4. Makes you wonder what PTS1 is, right? So that's where the command was run from. And then this column right here is the most interesting one. This is the process ID. And like most things in operating systems, having a process, a file, just about anything that we work with, there's a view of it that the user wants, right? I want to think of this as, the bash command, and there's a view of it that the code, the operating system wants, which is usually something like an integer. So, when we do an ls-i, we see all of my files. I call this file subdir, but the system calls it file 5226821, right, by its inode. So processes are the same way. I think of this as bash and ps, but the system thinks of this as process 29541. So it's the internal code that it uses to refer to a process. And someone asked in chat, yeah, if I open up a new tab, same thing. This new tab is now PTS3. And I can drag that out, or I can just create an entirely new process. So it's a session of Unix. And if you log into the Linux server and you do a PS, you'll see a PTS. If you log in a second time simultaneously, you'll see a different TTY. All right, so this is the process ID. This is the thing that identifies the process internally. So it's usually just an integer, 32 or 64 bits, depending on your architecture. And so that's the PS command. So so I can do commands like sleep. I can say sleep 1,000, and this sleep command just says go to sleep for 1,000 seconds. And so whatever I type on here doesn't make any difference. It's not listening to standard in. Its job is to sleep. And if I want that command to exit, I can hold down Control and press C. That kills my job. And if I do a PS, I can see that job's not running. The only thing running is bash and PS. Bash is my bash session, the thing that's giving me these prompts right here. PS is this command that I just ran. Right? And its process ID is 31981. Well, if I say PS again, PS's process ID is now 31992. It's a different process ID. It's a different process. This was the command that I typed right here. This is the command that I typed right there. But it's the same bash process, 29541. That hasn't changed from the beginning of this. So every time I type a command, it's a new process. It has a new process ID. It runs, it exits. Sleep 1000 would eventually exit, but it's going to take it a while. Alright, so if you want to kill the process, you do Control-C. But sometimes you might do a Control-Z. Control-Z is totally different. Control-Z does the following. It prints a Control-Z, and then it says bracket 1 plus stopped, sleep 1000. Alright, if I do a PS, guess what? I've got a third process now called sleep. So when you Control-C, that kills the process. The process is gone. When you do a Control-Z, it simply stops the process. Alright, so think about it like a car going down the street. If you Control-C, poof, it's gone. Doesn't exist anymore. If you Control-Z, it simply stops it. Hit the brakes, don't go any further. But the car is still there. Right? So my sleep command is still here. This process still exists. It's process ID 750. If I do PS again, it's still there. It's process ID 750. And so the downside of using Control-Z is if you really wanted to kill the process, but you just do Control-Z, the process is still there. And if I do a sleep 2000 and I Control-Z, and I do a sleep 300 and I Control-Z, I've got 3 sleep processes still out there. They're taking up resources. They might be taking up time. And, you know, I have control of bash. I can type stuff and it'll listen to me and respond. But those processes are still running. Or still existing. Alright, so let's say I want to interact with these jobs. I did a Control-Z which said stop this process. Let's say I want to start that process again. I can say FG. FG is short for foreground. And it means take that process and bring it back to where it was before I hit Control-Z. So we've got some command. When you hit Control-Z, it stops. When you hit foreground, it starts. It basically undoes the Control-Z. And now it's as if I had just typed sleep 300, and you know it's ignoring whatever I type because it's running the sleep command. If I Control-Z, it stops it again. If I do FG, it starts running it again and it's back to where it was. Alright, so we can interact with jobs like that, but sometimes it's useful to say, hey, I want to run this job, but I want it to run in the background. I want this sleep job to keep running, but I want to be able to continue interacting with bash. So if I say BG, that means background. It now says, oh, this job is in the background running, but I'm back to where, you know, I can talk to bash. So this job that was sleeping 300 is in a different state from the others. Alright, so a better command than PS for this is jobs. And if I say jobs, I can see exactly what's going on. Sleep 1000 is stopped because I hit Control-Z. Sleep 2000 is stopped because I hit Control-Z. Sleep 300 is running because I said BG, which means run it in the background. Alright, if I want to bring it back into the foreground, I can say FG. And this time it brought my sleep 200 into the foreground. Sleep 2000. Why did it do that? Well, there was a little plus sign next to this number. So let me Control-Z that and look at jobs. So if I want to bring back like my sleep 300, that's got a 3 inside angle brackets, I can say foreground job 3. And now I'm executing the sleep 300. And I can Control-Z it to stop it. And now all my jobs are stopped. And if I want to tell the sleep 1000 to start running in the background, I can say background %1. And now job 1, sleep 1000, is running in the background. If I want to bring sleep 2000 to the foreground, I can say foreground %2. And now I'm executing the sleep 2000 command. And, you know, that's taken precedence over bash. Alright, if I want a job to go away, I've got a few options. Let's say I want to get rid of that sleep 1000 command. I can bring it into the foreground and hit Control-C. And now it's gone. But I can also say something like kill %2, and that'll kill my sleep 2000 command. So if I say kill %2, my sleep 2000 command has been terminated. That means the job is dead. And now if I look at jobs, all I've got is job 3. And if I kill %3, well, it didn't say terminated, but it's not going to interrupt me. And I came back to my prompt a little bit before this job was actually terminated. And bash is usually pretty good. It won't start sending things to my output while I might be in the middle of typing. So the next time I hit enter, it'll say terminated. I'm seeing slow falling precipitation outside. That might be worth checking out. Alright, so that's a little bit of how we can interact with jobs using Control-Z, putting things in the background, foreground, and so on. So what I want to do tomorrow is look at how we send messages to jobs. What actually happens when we hit a Control-C. Because Control-C doesn't just kill your process. It does what's called signaling. It sends a message to the process, and the process typically responds to that message by exiting. Well, we can change how that works. So we'll talk about signals and signaling in bash. We'll dig a little further into the PS command, and then I want to start looking at this inside C and see how processes come about and how we can interact with them from C code. So lots of good stuff coming up. Alright, that's all I got today. Have a good one. I will see you next time.